So what we're going to start talking about in Unit 2 is how to make a compound in terms of writing the formula and also naming it. But the other thing that we are going to distinguish is what we call ionic compounds versus something called molecular compounds. So this we're just going to start out with. Things with charges are called ions. And maybe you've heard of this before, but we have what we call cations and anions. Cations are positive, anions are negative. So the T in cation is positive, so that's the T if you think of T as the plus, and anion is then going to be the opposite. When we make compounds, okay, we have to get the charges equal to 0. So when we make these compounds, what we are trying to accomplish is getting the same amount of positives, the same amount of negatives to get it to 0. So in an ionic compound, it is always the combination of a cation with an anion. So it's always with something with a positive charge and something with a negative. Like we understand positive and positives don't get together, negatives and negatives don't get together. So we always are combining a positive with a negative. Metals are going to combine with non-metals. So when we look at a periodic table, we could classify things based on where they are on the periodic table. So if you have your periodic table, the things that are on the left-hand side are metals. The things that are on the right-hand side of the periodic tables are considered non-metals. So there is a dividing line that you could draw in where aluminum is, and it's kind of a staircase. So as you go down, these strong lines are separating the left-hand side are the metals, the right-hand side are the non-metals. So you always are combining with ionic compounds, something for the left-hand side of the periodic table versus something with the right. So metals are going to be your cations and non-metals are going to be your anions. So a binary compound are going to be what we start with, are combining two element symbols together. So binary meaning 1. So on your periodic table, there are certain elements that have certain ion charges. So this first column on the periodic table, it is a +1. Second column over is a +2. Likewise over here, we have -1, -2, -3 in these columns here. So that's going to be something that you're going to need to know when we are doing these binary compounds. So binary compounds, two ions combine to form a compound. The charges need to equal 0, and we are always going to list the cation and then the anion. And as I do these lectures, please note that you could always stop the lecture and pause if you need to copy down some information. So these videos are going to go relatively quickly, so if you need that. So sodium is in the first column on the periodic table. And again, it's just going to take you a little bit of time to get used to where things are on the periodic table. So sodium is a +1 charge. Chlorine is a -1 charge. So think of it as I am putting together a +1 and a -1, just like in math class. Well, if I add them up together, I get the 0, okay? So in chemistry, we write NaCl together. Now we write subscripts to say how many we have of each, but because this is a subscript of 1, we don't ever include 1s in our writing of compounds. So we put this together in a 1-to-1 fashion, so we write NaCl as our compound. So what if you have something that has two different charges, okay? So sodium getting together with oxygen. Now oxygen is over here, okay? It is in a -2 column. So sodium is a +1 and oxygen is a -2. If I just added them together that way, I would not get to 0. So what do I need more of is I need more of the positives. So I need 2 of the positive 1s to add up to 1 of the -2s to get my formula to equal to 0. So how I write that in chemistry is a subscript. So Na2O is my formula for sodium binding with the oxygen at a -2. So that is a binary compound. So what if we have the other way? What if this is +2 and this is -1? Doesn't matter, okay? Again, on the left-hand side, calcium is in the +2 column, okay? It has a +2 charge. And fluorine over here is in the -1 column. So this is a +2, and this is a -1. So how do I get that to 0? Well, that means I need 2 of the negative ones. So when I'm writing the fluorines, I have to include the fact that there are 2 of them in order to get this to 0. So I write CaF2 as my formula, CaF2 as my formula. So where it gets more interesting is what if I have a +2 and a -3? Okay, I can't just take more of the calcium because that won't get me to a 0. So what number does 2 and 3 have in common? 6. So I have to get this to 6. So what I'm doing is essentially I need 3 of the calciums as a +2, and I need 2 of the nitrogens at a -3, because this will give me a +6, and this will give me a -6. So how do I write that? Well, calcium, I need 3 of them, and nitrogen, I need 2 of them. Now, please notice that the charge of calcium was a +2, and the nitrogen was a -3. Essentially, what I'm doing is bringing those numbers down. So that's kind of an easy way to kind of do some of these formulas, is to kind of crisscross them. So see if you could write the formula between Al as a +3 charge and S as a -2. So because the common number is 6, I need to multiply, or essentially I need 2 of the aluminums and 3 of the sulfurs to get that to a 0 charge, to get that to the 0 charge. So that is how you make binary compounds. You just got to get them to 0.